Hey guys, welcome back to the channel. In today's video, I'm going to explain how to add auto bed leveling to your Monoprice Maker Select V2 without changing the existing mainboard. Although there are several different ways to go about this method specifically will require changing from Repetier firmware to Marlin firmware, so if you're not interested in that, this method may not be for you. This was my first printer, so I used to prefer Repetier firmware, but now that I've been using Marlin for a while, I actually like it a lot better. To follow this method, you're going to need the following things: a 12mm diameter 6V to 36V inductive or capacitive sensor, an Arduino Uno, a 9V power adapter that will work with the Arduino Uno, some Arduino jumper wires, a mount that you can print to mount the sensor on your printer, and longer M3 screws to make up for the extra space needed for the printed mount. I'll include links to all of these things in the video description below. Also, I'll include a link to download the Marlin firmware that you will need to use. The first thing you're going to want to do is print a mount to hold your new sensor on the X carriage. You don't have to use the same one that I'm using, but the firmware is already configured to work with it. If you decide to go with a different mount, I'll add a section at the end of this video explaining how to change the firmware to match. Once your mount is printed, you can install it on your printer with the longer M3 screws, then place the sensor in the mount. Don't worry too much about the height of the sensor at this point, we'll adjust that later. Just make sure the bottom of the sensor is sitting up higher than the tip of your nozzle. Before you start making any changes to your printer, now would be a good time to make sure that your Uno works. Plug in the power adapter to the Uno and make sure it lights up as expected. If you haven't already updated the firmware on your Maker Select at some point in the past, you will need to burn a bootloader to the board before you can do this. But that will be easy enough using the Arduino Uno that you will be using for your auto bed leveling system. Check out my video here or in the description below where I explain how to burn a bootloader and write firmware to your Maker Select. After you've already burnt a bootloader and written the included Marlin firmware to your printer's mainboard, you'll want to write an auto bed leveling sketch to the Arduino Uno that you used earlier. Download the sketch from the description below, copy the folder from the zip file to your desktop, then open the autobedleveling.ini file inside. You should already have the Arduino IDE installed on your computer if you followed my bootloader and firmware video, so when that sketch opens up, connect your Uno to your computer with the USB cable. Then in the Arduino IDE, click on Tools, Boards, and select the Arduino Genuino Uno board. Also under Tools, select the correct port for your Uno, then click on the arrow button to upload the sketch and wait for it to finish uploading. Now you'll need to do some wiring to hook up the sensor. You'll notice the sensor has 3 wires, a brown, a blue, and a black wire. Brown should be your power wire, blue is ground, and black is the signal wire. You can either cut a couple of Arduino jumper wires in half to splice into these wires, or if you want to get fancy, you can crimp some actual JST connectors onto the ends of your sensor's wires. Either way, you want all 3 wires coming from your sensor to end in a male pin so that you can plug them directly into the Uno. The brown wire will plug into the 5V pin, the blue wire will plug into the ground pin, and the black wire will plug into the digital 10 pin. Next, take 2 male to female jumper wires and plug the male ends into digital 2 and digital 3, then unplug the Z end stop switch from the black plastic connector and plug the female ends into the 2 pins on this connector. Make sure they slide all the way down on the pins. It shouldn't take too much pressure, so if you're pushing very hard, you may need to rotate the jumper wire a quarter of a turn to get it to seat properly. Or if your printer doesn't have one of these plastic connectors like mine does, you can also splice these wires or use a JST connector with male pins to connect to. The wires on my printer aren't labeled positive or negative, so the orientation at this point is just a guess. Don't worry if they're plugged in the wrong way, it won't hurt anything, the auto bed leveling system just won't work. Now at this point you should have the Marlin firmware installed the sensor mounted and hooked up, as well as the auto bed leveling sketch written to your Uno. Plug in the Uno using the 9-volt power adapter and make sure it lights up as expected. Then take something metal like a pair of pliers and hold them up underneath the sensor. If the sensor is powered correctly, the light on top of the sensor should light up. If the sensor isn't powered correctly, double check your wiring. If you used a different sensor than the one I linked to, make sure the positive wire is going to 5 volts, the negative wire is going to ground, and the signal wire is going to D10. Once you've verified that the sensor is working, turn on your printer if it isn't already on, and use the control box to move the Z-axis down until the nozzle is almost touching the bed. Don't use Auto Home or Home Z or anything. Just go to Prepare, Move Z-axis, and lower in 1mm increments until the nozzle is almost touching the bed. Now you'll want to adjust the height of your sensor. Ideally, you want the bottom of the sensor to be about 2 to 3 millimeters above the tip of the nozzle. You can do this by placing a zip tie underneath the sensor and adjusting the screws to set it in place. But make sure the tip of the nozzle is sitting noticeably lower than the bottom of the sensor, and make sure the light on the sensor triggers before the nozzle would actually touch the bed. After you've got the sensor in place, have those metal pliers you used to test the sensor earlier in hand, and use the control box to raise your Z-axis up about 100 millimeters. Then go to Prepare Auto Home to home all axes. You'll notice the X and Y axes home as usual, but then we'll travel to the middle of the bed so the sensor has a place to home. At this point, if your Z-axis starts lowering towards the bed, take the pliers and place them under the tip of the sensor. If the Z-axis stops lowering, raises back up, and starts lowering again, put the pliers under the sensor again and it should stop, then raise back up about 10 millimeters. If that is the case, congrats, you're wired up correctly. However, if the Z-axis only moves upward then stops after about 10 to 15 millimeters, you'll need to switch the 2 jumper wires that are plugged into the end stop wires and try again. Or, if the Z-axis starts lowering and doesn't stop lowering when you trigger the sensor with the pliers, then turn off your printer to stop it from crashing into the bed. You'll need to double check your wiring and make sure both jumper wires are correctly plugged into both the Uno and the end stop switch wires. After you've verified the sensor works as expected, use your control box to do an auto home and keep your hand near the power switch. Watch the Z-axis lower until the sensor triggers and races back up about 10 millimeters when it's done. If the sensor doesn't trigger in time and the nozzle crashes into the bed, turn off your printer immediately. Then turn the printer back on to raise your Z-axis back up and adjust your sensor height. Now your sensor should be working exactly as expected, so it's time to set the Z offset. If you didn't just home all axes, then do that now. After the Z-axis raises up off the bed about 10 millimeters and stops, you'll want to use Move X and Y axis on your control box to put the nozzle roughly where the sensor landed. It doesn't have to be exact, but as long as you're close, it should be fine. Next, place a sheet of printer paper under the nozzle and use the control box to carefully lower the Z-axis 1 millimeter at a time until the nozzle grabs the paper. Then raise the nozzle back up 1 millimeter. Now switch to the 0.1 millimeter option and start lowering the Z-axis 0.1 millimeters at a time until the nozzle grabs the paper again. Raise it back up 0.1 millimeters or until you can move the paper freely, then write down the current Z height on a piece of paper. Next, on your control box, go to Control, Motion, Z Offset, and write the current Z offset down. You'll want to add these two values together, and then change the Z offset to the new value. After you've changed the Z offset, go back to the control menu and click on Store Settings to store this change to your printer's EEPROM. Use the control box to auto home all axes again and wait for it to finish raising the Z-axis up. Then use the Prepare Move Z-axis menu to lower the nozzle 1 millimeter and 0.1 millimeters at a time until you get to 0. Look at the nozzle to make sure the nozzle height is roughly where you want to print at, and when you slice files, you'll want to print with the first layer height set at 0.2 millimeters. The last step to getting auto bed leveling working on your prints is to change the starting G-code in your slicer. You'll want to add a G29 command directly after the G28 command in whichever slicer you use. That will tell the printer to perform the auto bed leveling routine every time before it starts printing. And that's pretty much it. No more fighting with manual bed leveling, just slice and print. Make sure if you're using build tack or PEI that you clean the print surface with isopropyl alcohol before you start any print. And it's recommended that you clean PEI with acetone every once in a while to keep it working as expected. From this point on, I'm just going to be explaining how to change the firmware if you decided to use a different mount. Feel free to stick around for that, but if you just went with my suggestions, you should be done. So if you decided to use a different mount than the one I linked to, you may need to make a few small changes to the firmware to match the distance from the tip of the nozzle to the tip of the sensor. I already explained how to go about this in another video, so I'm just going to use the same video clip here. There are a few things you'll need to change in the configuration.h file. There's a couple of constants in the Z-probe options section called X, Y, and Z-probe offset from extruder. You'll need to measure the distance in the X, Y, and Z axis from the metal pin of the BL Touch to the tip of the nozzle, and replace those values for the three constants. For X and Y, you have to use an integer value like 1, 2, 3, etc. But the Z-probe offset lets you specify a decimal place, so you can be more accurate. Next, there are 4 constants for left, right, front, and back probe bed position, and you may need to update those depending on what values you've set in the offsets. Otherwise, it might fail to compile because the firmware is smart enough to know that the probe won't be able to reach the spots in the bed where you're telling it to probe. So how do you make sure it's right? There are 3 values, X, Y, and Z max pos, and 3 other values, X, Y, and Z min pos. These specify the size of your bed, and your nozzle should be able to reach all of those positions from min to max. But since the probe is offset from your nozzle by X, Y, and Z probe offset from extruder, you'll need to compensate for that. Well, that's pretty much it. If you made it to this point in the video, thanks for sticking around. Feel free to click the like or subscribe button if this video was at all helpful to you. It really helps my channel a lot. And if you or anybody you know are looking to buy a new 3D printer, consider checking out the GearBest affiliate links below for the Zonestar dual extruder 3D printer and the TiVo Tornado. Also, check out my last video where I built and gave my first impressions on the Zonestar. I'm still working on the review video for that, so I hope to have it up soon. Anyway, if there are any other videos or tutorials you'd like to see, feel free to leave a suggestion down in the comments section, and as always, thanks for watching and I'll see you guys next time.